Today, we're diving deeper into object-oriented programming. We are going to learn about what are called class attributes and class methods that let us practice more encapsulation of information and also abstraction as we design programs. We'll do a little bit of review as we go, but we're really going to focus on the new material that we're introducing. So we're going to look over what class attributes are, how they're different than the instance attributes than we learned about yesterday, and what class methods are and how they're different than the instance methods that we learned about yesterday. And I may get my terminology mixed up at some point. If you think I'm getting it wrong, let me know, because chances are I may just be having a slip of the tongue. We'll also take a look at what are called static methods in part 2 of the lecture. Do folks have any questions sort of about the big picture agenda for the lesson today before we dive on in? Okay, cool. I think this should be good stuff, folks. So these are all going to come up on the weekend assessment project that we are going to release to you all Friday. So all this is important. And as I mentioned, it's really important that you are writing code and working on coding assignments this week. You all should have at least one, ideally two, really ideally everything but the stretch assignment done from yesterday. If you don't, start thinking about how you can get some time to catch up, and if you want to set up a one-on-one with a TA or Francisco or myself. So classes versus instances. We learned yesterday about classes and creating instances of a class. And let me go ahead and write a little code just to kind of warm us up and remind us. And can someone help me? I think what I'm going to do actually is I'm going to do the thing that you all are doing of closing my eyes and pointing at someone on the screen. Let's just build out a really simple dog class. Owen, can you maybe navigate me through making a dog class where that has like a name and a breed and anything else you want to throw into the mix?
Yeah, so you would want to just do class dog and then colon, and then you're going to need your init method, yeah, and then in the parentheses you need to put all the attributes your dog will have, so name, breed, color, and then including self, which you already have, and then that can be it. And then underneath that init method, you need to declare those. So in self dot name, and if you want to make it private, you can do underscore before the name, and then self dot breed equals breed, self dot, and then so on for however many attributes you have. And then if you want me to keep going, we can add other functions, but that's
Yeah. Yeah,
your
let's do it. Let's add a few more. Let's add
okay.
a few more things to the dog.
So then we can also just have a function that every dog can do. So like bark, so like def bark, and then you'd only need a self element in there, and then you just need self dot. No, you could just do a print statement, like a F string print statement, and just say self dot name uh, just barked.
Awesome. And what about these underscores in front of all these variable names? You kind of mentioned making them private, but if I recall, like, when I how do I make Fido, by the way?
You'd have to declare that instance, so you could do Fido equals dog parentheses, and then you just put in each element, and it
Yeah.
has to be in the same specific order that the instantiate or the initialize method is laid out in order to instantiate it correctly.
Yeah. And if I recall, I can still do, print Fido.name.
Mhm.
So what's the point of naming those instance attributes with an underscore again?
It's just so it lets everybody know that you shouldn't be really calling like a setter method. From my understanding, you shouldn't really be changing those attributes. They should always stay the same. Or am I incorrect in thinking that?
You are half right. We absolutely can change these attributes, but we don't do it like I wouldn't want to do, and you may have been saying this, I wouldn't want to do this.
Okay.
I would want to use a setter, right? So how do I actually, and now that we've done this, how do I make getters and setters for these attributes?
So you're gonna want to do. So if like, what would you want to get set? There's the name, I guess, for this example.
Which ones do you want to, whichever ones you want to make
Just
getters and setters
we'll,
for?
we'll start with the name. So beneath all of that goodness, you need to set the I can't remember what it's called, but the app property
Decorator.
decorator, and then you just need to put underneath that your name underneath there. So like your name function. So that'll be just self, and then if you can just return self.name if you want to do something to it, like you can do like dot capitalize at the end if you want to capitalize the name. Um, you don't have to do that, but like you just needed to return self dot underscore name. So now underneath that, you can add more decorators. So like for the setter method, you do at name dot setter, and then from underneath there, you'll assign that function. You'll just need self and then new name. You'll need that
Oh
attribute in
yeah,
the
thank you.
or not the brackets, the parentheses, and then now below that, you'll just do self dot name equals new name.
Yeah, and self dot underscore name equals new
Yeah,
name. Yeah,
and then
exactly.
at that point, if you wanted to add like some sort of try except or some if statement, you could say they gave an integer or a string that's too short or too long, then you can do that. So perfect.
Yeah.
And then you'd want to do probably an else statement just to let them know that it didn't work. Um,
Yeah, I'm
yep,
using a bit of a different
yep, different method. Yeah,
pattern. Yeah, it might have made more sense to, yeah, there we go. Does that look okay?
yeah, yeah. The cat is skinned, so
Yeah, exactly. And in fact, if we go ahead and run our code, Fido, Fido just barked. Let's test that logic that we just wrote. Um, it looks like, oh, I'm not using the setter. That would be why. We can just test it out and we can say Fido name equals boat. Because here that setter logic doesn't get used.
you don't have the O at the end of Fido and
Oh,
Fido.name.
thank you.
Yep.
And there we go. And note that VS Code gave me a super useful hint, well, Python really, as to the error in my code here, name error, FID is not defined. Did you mean Fido for line 24? So it definitely pays to read the error messages. Again, you usually want to look at the very bottom or the top of the error message. One last question, Owen. Actually, I'm curious, now that we've made this getter, should we use it here in the bark method?
You could maybe, yeah. I don't see why not, because then you could just do instead
Yeah.
of the bark. Well, you couldn't do it in the. You could decorate the bark with at name.getter.
Well, and the good news is, and I apologize because this was a bit of a leading question. We don't even need to do that. Um, let me just bring the terminal up here if I can figure out how. There we go. Just the same way. So I could use, if I had another method, let's just say we made a byte method. Just the same way I can access instance attributes inside my instance methods, I can use methods inside each other. So I can do self.bark, and then I can say, and so similarly, we can use these getters and setters inside our other instance methods, which I don't think I showed explicitly yesterday, but I figured would be good for us to see, and it's sort of like a logical continuation of how classes work. And Owen, you did an awesome job, man. Thank you for letting me put you on the spot.
No problem.
Yeah, so folks, as you can see here, this byte method, this instance method, we can call another instance method inside it, and our getters and setters at the end of the day are kind of instance methods under the hood, even though now they're a little special because they're getters and setters, and we can use them inside these methods as well. James, yes, sir.
Does it matter the order? Because in byte is after the bark method, and then you called bark in the byte. If you reverse those two, would it not work, or does the order not matter in the class?
Great question. I think the order might matter, but I'm actually not certain. Let's find out. No, doesn't matter. So why doesn't it matter? We'll look at the Python debugger in a couple days, but the short answer is, why doesn't it matter? Because there's two steps here in the code when this code is run. And I am going to zoom this out a bit just so we can get an overview. The Python runtime, when we run Python on the command line, it basically goes top to bottom through the whole file. Right here, this is where we give it the blueprint. The blueprint for the dog class is created. This is before we've created a dog. This is before we've run any of this code. So the Python runtime reads in all this stuff about the class. So it has the blueprints, but it hasn't actually started building anything with the factory, right? And the issue that you point out is relevant in other cases if we try to use something before it's created. But in this case, byte gets defined, and Python probably says, all right, we'll see what this is later, and bark gets defined. We're not actually calling bark here, so we don't run into the problem of calling an instance method before it's created. All of these get defined, and this is before we've created a single dog. And then down here, as the Python runtime continues, we actually create a dog, Fido. We've actually used the factory to build a dog according to the blueprint, but we still actually haven't even called this method. And then that happens down here, right? So at this point, when I do bark, or when I do bite, when I do bite is when this code will actually get executed. But by that point, since all this stuff got defined up front, Python has the definition for this method. Does that help answer your question?
Yes,
Awesome.
thank you.
Yeah, great question. Great question. I wasn't sure, and then as I was talking through it, I was like, okay, but this makes sense why this works this way. Do folks have any other questions about our sort of review of that we might want to go over with this code with getters and setters and instance attributes and instance methods?
The Zoom chat has a question about the underscore
Oh, thank you.
and privacy.
Yeah, I was gonna have the same question actually.
Is that can someone explain what it means to be private? It's only a message to other people looking at your code, or does it actually do something to your code? The underscore is only a message to other people looking at your code. It actually does nothing to the code. That is correct. Other languages that are not Python let you actually, like the language will actually enforce it, so you can't do stuff directly to private variables, but Python does not do that. So we just have to, just the same way where, you know, when you're driving a car, you can run the stop sign if you want. The stop sign doesn't like make that a physical impossibility, but you know, we want to follow the rules. And it's the same idea with the underscore.
So is there a reason why name was underscored and like breed and color weren't?
Just for simplicity for this example to write less
Oh, okay.
code.
Gotcha.
Yeah. One, const is different in JavaScript. Const actually does enforce some stuff. To answer the question, is the underscore like const? No, because in JavaScript, const will actually enforce immutability for certain things. So we've gotten a bit of a review and a warm-up here of creating a class, creating instance attributes, right? We know that name, breed, and color are not set to be the same all the time for all dogs. It's rather that each individual dog will have their own attributes, right? Each instance of the dog class will have its own attributes. And we've seen that when we call our methods, our instance methods, they get called on the instance of the class, right? This should be Rover, not Fido, excuse me. If I do rover.byte, the byte instance method is not going to print out information about Fido. It's going to print out information about Rover. So to use another metaphor, because we're about to see how we can actually have some shared information between all the instances of the class. We're say like all dogs go to heaven. Maybe all dogs have 4 legs. All dogs belong to the same species. You can think about an instance of a class. It's sort of like a room in a building. And if you think about an apartment building, that's maybe a bit better because every apartment has the same thing, right? Every apartment has a kitchen and every apartment has a bedroom and a living room and a bathroom. And if we're in an apartment building, all the apartments have the same layout. But there's still some common areas in the apartment building. There's the lobby, there's a laundry room maybe, maybe there's a rooftop, maybe there's some sort of common area. So each individual apartment, each instance of a class has its own versions of things, but then we can still have some things that are universally shared and the same for all instances of a class. And so the term class attribute, instance attribute, or excuse me, class attribute, class method, that's what we're going to be talking about here. We're going to be looking at class attributes and class methods, which can be used by all instances of the class and will do and can be used to share information. The same way where, like in an apartment building, everyone can go down to the common room But say for an instance attribute, you know, we all have apartments with the same layout. Our kitchens are all, I don't know, 5 by 12, but you know, my kitchen has nothing in the fridge and your guys's has a lot of food in the fridge, and I'm in my kitchen and you're in your kitchen. Those kitchens belong to the different individual instances, but the laundry room, right, or the common lounge is shared by all of us. So let's see some code and see this in action. So we've been working with the dog class, and I think this is a good place to start. I'm also going to do just a little bit of modification here. To save us some screen real estate. I'm going to move all of this stuff over here into a runner.py file. And runner.py and example.py are in the same directory. And I'm just going to rename examples.py to, let's just call it dog.py. And let me actually rename it to be upper, no, I don't want to rename it to be uppercase, excuse me. In general, yeah, be careful with naming stuff uppercase. Sometimes you do it. I actually am not sure off the top of my head if the Python convention is to name the file uppercase or not, but it doesn't matter for us here. So now I can have the dog class defined in our dog.py file, and let me open that up. But we'll import it and we'll run it here, which is how a lot of the assignments are set up and how the assessment is set up. So let's add some universal attributes, some class attributes to our dog. Let's say, just for the purposes of our program, that all dogs have 4 legs. I know that's not true in reality, but for us, for this program, it will be. So class attributes, as you can see, we don't use self because self is about the instance of a class. It's about Rover and Fido, and Old Yeller. This is about all dogs, right? All dogs go to heaven. Class attributes apply to all dogs. And in fact, we can add is going to heaven true. And so you want to define your class attributes right below the class definition. I think you might be able to put them here. I'm not sure if Python would complain or not. But for readability and for your own sanity, put them at the very top above the dunder init method. And as you can see, we have an attribute name and the value. And let's give our dog one more class attribute, because all dogs belong to the same species, which is, and I'm looking at my notes for this one, Canis lupus familiaris. Hopefully I got that right. So this is how you define class attributes. Let's see how you use class attributes. We've got Fido and Rover. So the cool thing about a class attribute is it doesn't belong to any particular instance of the class, like Fido or Rover. By the way, like the the dog class definition itself is a Python object of some sort. Python probably has a special class named class or something like that. And in fact, they call it type. So this is our blueprint right here. The blueprint is also a Python object. What we can do that's interesting with class attributes is I don't even need to create an instance of the class. I don't need to create a dog to access that class attribute or use it. So as our programs get bigger, this is useful because maybe we have like 150 files and we have like 20 animals. And this way, when I import the dog class into one part of my code and I'm doing stuff, if I need to get this general information about dogs, I just have to import the class. And these things actually never change. We can add stuff that changes, and we'll see that in just a minute. But this is the basic idea of a class attribute, is that you can add these properties and they're true for all instances of a class. You can use them inside the class itself. For instance, in my dunder init method, I could say, let's make an f string, and let's say creating the dog is of species dog dot. Actually, I'm not sure if it will let me. Oh, actually, I think my issue may have just been with the curly brackets. And now if I go ahead and I create Fido, right? What the Python runtime is doing is it goes through runner py, imports and reads in the blueprint, says, oh, I can give you some information about the blueprint. I can give you these class attributes. Oh, we're firing up the factory now and we're creating an instance. Call the dunder init method that belongs to this class and do all this stuff, right? And inside here, I can use these class attributes. And if I wanted to, I can even, maybe I want to write a dunder str method that returns some information about the dog. And here we could say, you know, name self.name. Maybe for every dog, I want to print out maybe I want to print that information out for whatever reason about Fido. So you don't need to use class attributes all the time. They are just another tool in the toolbox. I am going to bump the font size down a touch just because I don't think I can get everything I need on the screen real estate. So if this is a major pain point, let me know. So I've been doing a lot of talking. Let me just pause and check in and see what questions people have. Ryan, yes, sir.
So I guess say you had multiple classes and you're making a lot of instances, and you had class attributes for all those classes, and you
Mhm.
forgot what Fido was. So then you wouldn't really know to call the dog dot species to figure out his species. Could you still do Fido dot species, or do the class attributes only work if you put the class name there?
That is a great question. Let's find out. So VS Code is not complaining yet, which is always a good sign. And if we look at line 18 here, and everyone can see this sort of like red annotator laser pointer, correct? Okay. Is it big enough to be useful? Okay, perfect. I've been assuming so. I figured I would just check. So we see that line 18 gets printed out right here. You can do this. You generally want to avoid it for reasons of clarity, because we might have, for whatever reason, like I could have a class attribute, an instance attribute, excuse me, named species. In this example, it wouldn't make sense, but in a different example, maybe you have two things with the same name or something. And know how this overrides the class attribute. And also, if I'm looking at line 18 of the code and I see dot species, I don't know if it's a class attribute or an instance attribute or what. So at least starting out, my recommendation is access class attributes and class methods off of the class. That way, when you're looking at your code, you'll know where it's coming from. Does that help answer your question a bit?
Absolutely, thank you.
Yeah, for sure. I'm sure there are valid situations to do that in Python. I should actually double check that. My general preference is for clarity and explicitness. And I like this because if I look at this code, I know what this is and I know where it comes from. If I see Fido.species, I assume this is an instance attribute or like a getter and a setter. And frankly, programming is complicated enough. Every time I see Fido.species, I don't want to have to think about like, is this an instance attribute or is it accessing the class attribute? I want to just be able to look at my code and know. And as to your point, we can absolutely make a cat and do some of this as well. And we can define some class attributes for our cat. And I don't know the species of a cat off time. We'll just say, but cat species. And as far as I know, all cats don't go to heaven. I don't know if all dogs go to heaven is from a movie or what. So in our case, the cats, they're just in trouble. And, you know, as you're writing multiple classes, you get to make design decisions. We'll learn about inheritance tomorrow. But for now, let's say, you know, we decide that my animals, my pets, I want to pass in the same arguments for consistency in the dunder init methods. And in fact, I'm going to steal most of this code. You guys should not do this because the actual typing and the muscle memory is important. But in the interest of time, I'm going to do that here. And so cats obviously don't bark. They meow. And the problem is they don't meow before they bite, they hiss. So we're just gonna have the cats bite in silence. Right, so now I can have a dog and a cat. And the same way there's this information about dogs. Over here, we can also have the same information about cats. Friend, cat species. Let's also make Garfield. I don't know what breed Garfield is, but I know that he's orange. And if we run this code, we see our cat stuff as well. What other questions do folks have? What else is on people's minds? This is a good check-in point. There's a little more I want to show with class attributes, and then we'll break on the hour to get a solid hour of work time in. And I'll talk a little bit about what they're good for too.
Yeah, I have a quick question. 2 parts. Can you change a class attribute, and would that even be appropriate? Like, say you run one function and you want that attribute to be legs equals 4, and then say like you run into some data where you know those dogs are 3 legs. Can you change the legs to 3? That's, I guess my question simplified is like, would you ever want to change a class attribute, and is it even possible?
Yeah, great question. You can. You do want to sometimes, and I'll talk about why in a minute. Let's go ahead and change it now and see what happens. And let me pull up my terminal. So just to kind of recap what we're doing here, and this is a great question, Owen. This class attribute of legs for the dog, we're going to try changing it to 3 over here, not in the class definition, but where we've imported the class, and we're going to see if that works. And then we'll talk about if that's a good idea or not. I think it will work, and it does work. So, do we want to do this? The answer is, it depends. It depends on the kind of information. Sometimes we very much want to do this. Sometimes we don't. And just like I was saying, how variable names and naming conventions are like stop signs and, you know, traffic lights for other programmers, right? Like the traffic lights don't magically make it impossible to run a red light. They just explain the rules of the road for everyone so we don't get traffic jams. It's the same thing with naming stuff. So if I was writing this code, let's say we're making a game or something where in our game, all the dogs are going to have 4 legs. Though I agree with you, for most things, we would want to think about pets with 3 legs. Remember I said the convention is if you create a variable where the value should not be changed to name it in all caps. So here's a good example of where we could do that. And now, yes, we can change legs or these other things, but we really shouldn't. And let me just fix the code here so it, and as you can see, the advantage of this is when I'm reading this code and I see these variable names or these attributes in uppercase, and we really should do this for cats too. I'm just not in the interest of time. I'll follow up and I'll change it later. Now I understand, okay, this is meant to be a constant. This should not change, right? In our animal adventure role-playing game, dogs have 4 legs. So when should we change this stuff? Let's talk about that. And I think to show that example, I want to use a new class, and we're going to switch from animals to students, which also touches on what you all will see in your assignments. So let me make a couple files. I'm going to make a file named student.py. And let's open that up here. And let's maybe just name it runner students.py. Normally there's only one runner, but I've so much stuff in here. I want to keep it a little organized. But I need to rename that. There we go. So I'm going to make a class named student, and I'm going to make the class first. I'm going to make it empty so that in here I can type from student import students, and it'll work just fine. And just for fun, there's nothing on here, but let's just print student. Just to make sure I didn't do anything silly. And let's go ahead and run this code. So what do we want to do with this student? Student instance, each instance of a student, I think is going to need a name. We want to keep track of all the students. So students are going to have an ID and students are going to have an email. Now, student class attributes. I want to keep a list of all the students. And I want IDs that auto increment. So, 0, 1, 2, and so on. So I need to keep track of what the next ID should be. So those are my tasks here with the student class. Let's write a dunder init method first. And I'm not gonna do much. I'm not gonna do much with getters and setters at the moment, in the interests of time, but we absolutely could. And email is a great example of what to use a setter for to add some validation. I'll add a little to-do, make getters, setters for email and maybe for ID as well. And let's see what this looks like. And then I want an ID. And here I run into a bit of an issue because I want my ID to auto increment. So, when I do Alice equals student, Alice at gmail.com, I don't want to have to pass the ID. I want that ID to be 0. And then for Bob, I want the ID to be 1. So let's actually make the ID the class attribute. And over here, let's do student.id. And then let's do student.id plus equals 1. So that every time I create a student, we assign the current ID. So I'm choosing to start with 0 here. And in fact, maybe, all right, we should start with 1. And then I increment the ID. So let's create a couple students and see how this works. So I love print statements and I'm putting them everywhere. So what we're gonna do is we're gonna see what that class attribute value is. We're gonna see how it changes as we create students that runs this Thunder init method. And we'll double check the student IDs with these print statements as well. So it looks like, oh, I have those. That's why my order over here is off. So let's fix that. So when I look at my print statements, I don't have confusion. So it looks like this works, where we use the class attribute to create a student ID and we increment it. And this way I don't have to keep track of it in my code. We don't have to pass it in an argument, just like everyone uses the laundry room. It's the class's job to keep track of this sort of student ID counter. Each student still has their own ID, but this is the counter that we use. And in fact, if we wanted to, we could even rename this to like ID counter if we wanted to be really, really specific, which is not necessarily the worst idea. I do love, as I said, I love simplicity, and this way it's really explicit what this variable's job is. So I've been doing a lot of talking here, and this is, I think, a good point to pause and check in and see what questions folks have. What parts of this code might be good to go over. I see someone threw in, oh, Gary, thank you for sharing the species name of a cat. I will throw that in there later. What's on people's minds? What parts of this code are good to go over or play around with? So let's say I want to keep, oh yeah, go ahead.
I had one question. So if you deleted all the code from runner students and then put in new student variables again through the class, will it just delete it and start over the ID counter?
Oh,
Because yeah, it doesn't store it, right? Like it doesn't store it in the student class, and it's always going to just be one after you just delete all the like Alice, Bob, and Carol. So the
when
ID
you
will start
say
from one when you
delete,
do the runner again.
even if I comment this out?
Yeah, if you like comment it out or don't store, it won't store, right? So it'll start the counter over again.
So CM, let's focus on line 6. On line 6, when the Python runtime is, doing its thing line by line, and it gets to here, in the flow of execution for my program, where does it go next? Like when it sees this on line 6, where does the flow of execution of this program go next?
Goes
And
to
you can
line
always
9.
phone a friend if you're not sure. Line 9?
Does it go line 9? Yeah.
It does not. It's a good
Oh.
thought, but what do these two parentheses do here with the student class? It's like calling a function, right? And when I call a function, where does the flow of my execution go? It goes inside the function that I'm calling to do that stuff. What special sort of function are we calling there with student open parentheses, close parentheses on line 6?
The init.
Yeah, exactly. So the flow of execution goes here, right? That's what student open parentheses, close parentheses does. It calls that dunder init method for our student class. And so then the program goes here and it says, let's construct a new instance of the student, pass in these arguments, the name, the email, the ID, and here we increment, right? And it is here, and this is actually stored, right? This is actually stored on, this is where the blueprint metaphor breaks down, because this is stored in the blueprint. So if I never call that dunder init method, we never get to line 21, right? That increments the counter. So it's always going to stay at 1. So if I comment this out, and I comment this out, and I comment this out, and we'll comment these out because Alice, Bob, and Carol don't exist. The student ID counter is set to 1, right? Now, if I wanted to, I could do student.id counter equals 2. And now it's 2. And to answer the other part of your question, it is saved. It's our class definition is now holding some extra data, right? This is indeed being stored, right? So once we create this blueprint here, this ID is indeed stored. And so if I only create 1 student, then the student ID gets incremented once. Does that help answer your question a bit, Sam? I'm not sure if that helped or made it more confusing.
No, that helped. It just looks like whenever you call, like for example, make the new attribute or make Alice as an attribute, it'll add, for example, the ID counter. But when you take away Alice, it'll just go back to 1 because there's nothing being called in the init method. So I guess the next question, which you'll probably answer, is like, how do we store these values next into like a list or something else?
So
But that's next, I think.
yeah, we could actually delete Alice, right? I could create Alice and delete Alice, and this ID counter will still be 2 because the student class itself is holding this information. Like if we hop over to trusty TL draw here for just a moment, and let me draw this out, and then I think there's one more thing I want to show, and we'll take a break. And I think this is a good thing for us to dig into. And I'm making computer memory down here, and each of these represents, you know, like a location in memory. And let me just go ahead and give these names. And this is, you know, memory. Over here, let's say is the student class. And that actually happens from class student. And let's just say like ID counter equals 1. I'm just going to use name for simplicity. And self ID equals student ID counter. And when we I didn't want to bring it in today because it's a bit more, but I think using the VS Code debugger will also help illustrate this stuff. And this is a bit more of a complex concept for sure, and adds, I think, some wrinkles in object-oriented programming. So we have here a really simple student, right? And as soon as the Python runtime reads this code, let's say that my program, my whole program looks like this. Right? And then when I run this, you know, with like Python mycode.py, let's kind of walk through what the Python runtime is doing. So it reads this in, and then what it actually does is in memory sets aside some space for our student class definition itself, especially now that we have a class attributes and class methods. And so over here, what we have is, let's just call it student with a capital S, and maybe it's a dictionary. Let's pretend it's stored as a dictionary, or it could be an object, but it doesn't really matter. But this actually gets saved here before we even get to Alice, Bob, or Carol. Right? And in fact, if I want to play around with this code and do student ID counter plus equals 1, what happens, again, before we've even created a student object, the Python runtime reads this in, sets this, and then when it gets over here, it says, oh, this class attribute, its value has changed. And now this is 2. And then the Python runtime continues, and it gets over here to Alice. And it says, oh, I need to call dunder init for Alice. Let's call this and pass in this string Alice as a name. And it sets name, and it sets ID, and it sets the ID, and it looks over here to get it. And then it increments this. So what we end up with is, and let me get my typing right. We've got Alice dot name equals Alice ID equals 2, and that's it for Alice. And so then in memory, the Python runtime has asked the computer to save some space for Alice. And then when it's done, this counter gets updated to 3. And then the same thing happens for Bob, right? And then this gets updated to 4. And then the same thing happens for Carol. And then this gets updated to 5. So that ID counter is saved in memory, regardless of whether we ever create Alice, Bob, or Carol. Does that help illustrate it a bit, or does it just add to the confusion?
No, that helped a lot. That was a good question.
Yeah, great question.
At
Great
least for me,
question.
it did.
Yeah, was that useful for other people as well? Awesome.
Yes, that was a great question.
Yeah, yeah, great question, Sam. And let's see, in fact, if we can. I don't use the debugger a ton. I'm not going to lie, but let's see if we can't. And let me add some breakpoints. I thought this was installed. Let's see if I can't get this to work in like 30 seconds. I'll switch gears. There we go. That's what I want. So Alice actually gets deleted. Let's actually let's not delete Alice. Let's create Bob. Let's create Carol. And in fact, like I was saying, let's increment the student ID counter ourselves so we can see that in action. So all these little red dots are what is called breakpoints. I'll do a bit of a better walkthrough of the debugger later. I generally use print statements. But what the debugger will do will show us as we run through our code, what is happening in the computer in memory. I'm not sure if it's going to let me use the debugger for this file too. There we go. So I'm just adding breakpoints everywhere because I'm actually not a debugger expert. So there we go. So the breakpoints we won't worry about. The call stack we don't have to worry about. The variables are the relevant bit as we get into our code. So this is a little hard to see, and I know I'm kind of throwing it into the mix here, but what the debugger does is if you all see, and let me annotate it. See this yellow cursor over here? This is, we actually can pause the Python runtime as it executes and runs our program. So this is running, Python runner students.py. And every time we hit one of these red dots, it's going to pause. And we can actually see all the variables created in memory and their values. The call stack and other stuff, I don't want to get into it right now, but we can see function calls and stuff like that. And if I can just remember the right buttons to push, I think we can step through this debugger, and the commands are up here that continue running and do other stuff. So right now we've called that dunder init method. I think we're just reading the code through for the first time. So you can see over on the right, it hopped over to printing out students. And if you look in the terminal, do you guys see that class student just got printed? Right, so this is where we are in our code. So let's go through this step by step, and this is actually really good to see. So we're about to print that next print statement on the right side of the screen. And you all see that got printed out down in the terminal. Cool. So note, by the way, over here, a variable has been created to hold the student class, and the ID counter is set to 2. And in fact, let's, I don't know if it'll let me do this way. So we can watch the student ID counter here change as we step through this. So we've jumped into the dunder init because I think because we hit line 7 where we're creating Alice. And if I look over here at these local variables, email and name Alice, I see that that's correct. And just like I want to say it was Juan saying it the other day, when you call a function, these arguments get created as variables, but then as soon as the function is done, and this is true of methods, of instance methods too, they're deleted. So email and name are created, but they're going to be deleted. They're going to get added to the Alice object, and that's what gets saved. And let's watch this happen. See, now self has name, has Alice, and it has ID. Right? So, and we don't really have any global variables because everything is inside of class instances. We're about to increment that student ID counter that exists on the student class. And now it's 3. And note how we now have a variable for Alice that's an object. There we go. And Alice is now a global variable because she was created in the top scope of runner students.py. We didn't create her inside a function. We didn't create her inside an if block. We created her at the top level of the program. And the runtime keeps track of, for the different classes, in this case, we just have student, the class variables are the class attributes. And so as we run through this, we can see that this is going to happen with Bob. And note how the runtime and the flow of execution goes into the constructor, again, the dunder init method. And this is really what you want to practice when you're looking at code and thinking about code and reading code and writing code, is to build your mental model of exactly what the computer does line by line. Right? And that's what I mean by flow of execution. And that's where I think the debugger is super valuable in visualizing some of this stuff. Like in school, we would do a lot of this on a whiteboard or write little programs on pieces of paper and have to talk through them. And that's really what you want to build, that mental model of what the computer is doing. And now note that ID counter has been incremented to 4. We now have Alice, Bob, and the student class. And now I'll take it home with Carol. And then our program completes. So I'm not an expert at the debugger. I usually use print statements, but it's incredibly powerful. And I think for visualizing can be very useful. So I hope that that helped visualize a bit what's going on under the hood in terms of how variables get stored in memory, and in particular, these class attributes, right? And how they do indeed have their own home in memory. Was that helpful or a little bit of information overload? Awesome. I see a bunch of thumbs up. Cool. And we're going to revisit the debugger. I think I'm going to ask some students, if any of you are particularly into it, I think it'd be great for a student-led demo. We don't have a particular lesson on it. I'll try to show it a bit more as we get into the week as well. I like print statements. Like when I'm learning stuff, like what I would do if I wanted to better understand the flow of execution is I would just like stick a print statement here and be like, print, in, init, made, name, and email, or whatever I need. And I would have like 50 of these things. And that's a great technique as well. Sort of like I've heard the like tracer bullet metaphor used before to help see the flow of execution of your code. And the benefit of print statements is they're easy to write, they're easy to comment out. So both are really good techniques. So there's one more thing I want to show. I know we've been running long, and then we'll break, and we will have a break and work time before we reconvene at 11 Central to learn a bit more about static methods. And this is just a variation on the theme. Now that we've done this deep dive, I think this will actually feel a lot more straightforward. And that is the second part of what we want to do here, which is keep a list of all the students. And so here, I am just going to create an empty list named students, and I'll name it all students as a class attribute. And let me close out that comment block so we can see the code better. And then what I'm going to do, whenever I create a student, I want to add them to the list. How can I do this? That self keyword represents the instance. It represents the student. In the debugger, when we saw that variable Alice and that variable Bob and Carol, well, when I'm working within the class definition, self represents that variable. And so I am going to add a student to this list every time we create one. And as I said, I really do love print statements. So I'm going to add a print statement here. That's an app string that's going to say student, all students is And in fact, yeah, I think I'm just going to do it like this. And I'm just going to add it after every student that we add. And let's run our code. I'm not going to use the debugger in the interest of time. And so there's a bunch of stuff here, but what we can see is just like with that ID, our class attributes can be anything we want. Dictionaries, they can even be other objects, instances of some other class. And in this case, it's a list. And we are adding the students to it. Now, I haven't written a DunderString method, so we don't get very interesting information. But we can see that that list had nothing, and then one thing, and two things, and three things. And if I do write a quick DunderString method, that returns the name, and we run our code. Well, this doesn't actually work. The reason this doesn't work is I have a list of objects. DunderString works great for print. If I have a list of objects, there's another Dunder method called repr, which is short for representation. And this is usually used a bit more for debugging. DunderString is maybe for printing output to users. And so there I can see my student names. So this, I think, is a good pause point and to break for you all to work on a really similar coding assignment. Before we break, I want to see what questions people have or what might be useful to go over when it comes to this class attribute and the feature we just added of a class attribute of a list that holds all the students. Okay, how are we feeling? Good? Semi-good? Somewhere in the middle? Cool. All right, let me quickly show you guys the assignment we want you all to work on. And then we'll break and have some work time. And I think it'll be good to help get your hands on it. So this is today in the curriculum. We've just finished up part 1 of the lecture. Part 2, we're going to see that you can actually make methods, class methods, and something called a static method that that we'll learn about then. But the assignment I want you all to work on is called car management. You're going to create a class named car manager, and we've kind of given you the things to create. So we want you to create some class attributes. All cars, that's a list or a dictionary, up to you to keep track of all the cars that you created and the total number of cars. And then we've given you a specification, a spec for how to build the Dunder init method. Start here, write the car manager class, write some print statements to test it out, or if you want to, you can write PyTest tests. Get this working. Once that is done, then move on to the part of getting user input and step 2. This is great, and this is great practice, but this is the core, right? Because this utilizes everything we just have been learning and is in many ways similar to the student class that we just built. And I'll push that code up to the demos and notes repo. So let's break so that we will have 40 minutes so you have enough time to get off the screen and get some hands on the code. I'll throw this link in the Yankee channel, but again, this is in the curriculum repo. And then we'll reconvene at 11 Central. Do folks have any questions before we break? Okay, awesome. Let me go ahead and stop the recording and open up breakout rooms. All right, so the plan is I'm gonna build out part of the car management system. I'm not sure if I'll be able to get to the whole thing, but I think I'm gonna try and build out as much as I can from the assignment. And that's gonna lead into looking at class methods and static methods. So this first part of demoing and building it out, I'm gonna move through a bit more quickly to make sure that we have enough time to focus and spend some time with those other concepts that I think will just add to the car manager. Does that sound good to folks? Awesome. So the way I like to do it, and what I've done here is I just made a directory that named car manager, and I have car manager py, runner py, and a notes file. What I like to do is I love lists. I really love lists. And I'm gonna keep getting VS Code squigglies because I have a markdown formatter. So I'm just gonna make this a text file. I really, really, really like lists. So when I look at these instructions for the car manager, what I see is, what do we need? I need all cars. I need to decide if it's a list or a dictionary. I'm going to make it a dict, and this is a class attribute like we were learning about. Total cars, this is an integer. It's also a class attribute. So these are two features of my class that I need to build. I then, like with every class, I'm going to need my dunder init to create a new car. And if I look at it, I know I'm going to need ID, make, model, year, mileage, and service. I think what I want to do is have ID be auto generated so it doesn't have to go in the dunder init method. And I know I need getters and setters for make, model, year, mileage, service. The way I like to do it is to break this up into tasks, where let's start with a really simple car that just has a make, and then let's give it a model, and then let's give it a year, and then let's give it mileage, and then let's give it service. And we also are going to making these dictionaries, these are going to be their own tasks. And this way I can chunk up my work into little itty bitty pieces. For the very simple first version of this, I am not going to worry about any sort of validation logic. I'm going to write getters and setters, but they're not going to do much. To me, that's stuff I want to add later once I have the term is MVP or minimum viable prototype working. Same with the terminal program. I'm not even going to worry about this right now. Because this way, I can start really simple and work with what I know. And the first thing would be making sure that my runner.py is right. Because usually I get sort of the VS Code autocomplete helps me. And I'm wondering if maybe the dash is the problem in my file name. Let's see if that helps at all. And indeed, that solved it. I'd forgotten this, but I guess Python does not like dashes in its module names. So I'm gonna remember to name my files snake case. But this is why I love doing stuff in simple steps. I love doing stuff in simple steps. And in fact, let's just even like give this a dunder str method. Well, we'll get there when we print out the car. But I love, let's just print out car manager, and it's not even going to have anything. Let me actually run my program. Excuse me, my fingers got ahead of my brain there. And let's add an F string. So I have a little more information about what this is. And let's add these class attributes. Let's make all cars an empty dictionary. And I'm going to go ahead and run my code. And let's go ahead and let's make, I'm just going to call it, I'll call it ID counter again. Or excuse me, it's number of cars. So let's call it num cars. And that's a class attribute, and that's going to be set to 0. And again, as we saw with that TL draw visualization, Python actually puts this stuff into its own special spot in memory. And so now, without even having done any work with Dunder init or anything like that, I already have working code. And in fact, these two tasks are partially done, right? I need to make sure that now, like, all cars gets updated and num cars gets updated. And, or excuse me, the instructions call for calling this total cars. So let's fix that right now. And I'm going to run my code again to make sure that I didn't have a typo. And now let's go ahead and start building the dunder init method for our class that's going to do stuff. So I can get rid of this pass. And let's do def init. I know that my dunder init method needs to start with self. And I need a make. I can never remember. Is make the manufacturer like Volkswagen,
Yes.
Ford? Yeah. And I know this is going to be a getter and a setter. Thank you. So I'm going to do self make, and I'm just going to make my getter right now. And I realize, you know, I've been doing this for a long time. I can type pretty fast. Speed is not the objective here. Like organization and process and workflow is the objective. So what really matters is just starting to work on your process and your workflow. And this is where I really think having a task list is invaluable. And you know, let's look at the instructions. Let's see if we even need to create setters. Because to be honest, if I don't need to create a setter right now, I'm just going to skip it. So indeed, these should be protected. But if I look in the instructions here, I don't think I'm actually told I have to make a setter. So sure, that'd be nice, but I'm not going to worry about it right now. I'm just going to add like a to-do, make setters for getters, question mark, and worry about it later. I don't need it as part of my minimum viable prototype. And this just makes it easier for me to get the important stuff done faster and have less typos and errors and debugging. And let's just make a Ford. And this is all that my car can have right now because that's all that I've done. I will, just for fun, I think it's make dot lowercase, and then I think this is make dot capitalize. I will do that. And I am going to, let's go ahead and print for.make and make sure this works. And I totally forgot what the right, does anyone remember how do I lowercase something in Python?
I think it's just lower.
Let's see if that does it. Awesome, thank you. And again, this is the benefit of running your code all the time and doing work in tiny chunks. You know, if I had to Google that or look it up or ask ChatGPT, it becomes super easy. And at this point, I am also going to add a dunder string method because it's going to make my life easier. I'm actually going to add a dunder repr method, which works both for print statements and if this is part of a list. It's used a bit more for debugging, but it's a little more flexible. And I'm just going to do self.make, and I'm going to use my getter right there. And I'm going to use this vertical pipe in the text to separate as I add my different things. And so now I can simplify this, and my testing as I go with print statements becomes easier. And let's go ahead and do the same for model. And what are the other attributes we need? Year, mileage, and service. If I was doing this for real, I would actually just add model and then add the getter and add it to the repr and test it. And then when that's done, add year and service and do it all sort of step by step like that, end to end. I recommend you all do that because as you can see, breaking it down into tiny chunks this way, doing it end to end, using print statements for your own sort of informal TDD makes each little step absurdly simple. In the interest of time, I'm gonna build all these out. But again, this is if I was doing this for real, this isn't how I would do it. And this is just a workflow that I learned over years and years and years that really I think helps a lot. So make, model, year, mileage, service. I don't want to have to remember the order of things, so I'm going to add defaults. The capitalize is going to throw a problem. If make is none, it'll throw an error. So I think I'm getting a little lost in the sauce here. I think I'll just make these be empty strings. Not sure that's a little year should definitely not be a string, that should be none. Mileage is going to be a number as well. Service, let's see what the spec says service should represent. A list that will store the services done to the car. So let's make this an empty list. And then over here, let's do self model equals model.lower. Self year equals year. Self mileage equals mileage. Self service equals service. And I need to add my underscores. And I'm going to do a little copy pasting. Again, I recommend actually typing it all out for learning purposes. Copying and pasting is actually more trouble than it's worth because there's always the one thing you forgot about to change, and then you introduce a bug. Excuse me. And then we have, let's see, make, model, year, mileage. As you can see, there's also a big advantage to using consistent patterns in the code because I don't really have to think about this too much. And now over here, I'm just going to add self dot model self dot year, self dot mileage, and self dot service. And now over here, I'm just gonna expand on this a Ford Focus from, I don't know, 2000 with 100,000 miles and the service. Now, this is where it gets a little interesting because service is a list. And I actually didn't think about this. How do I add something to the service? Well, here, I think we can pass a list for the constructor. Let's test this and see if it works, and then we'll revisit service. So I'm cooking with gas. Let's revisit service. I want to be able to add something to service. I don't want to replace the whole list. It's a little bit of dealer's choice. You can use a setter for this. I like using a method, and I'll show you why in just a second. And let's just, for fun, to make life easier, service added services, and we'll do self dot service. I like doing this as a method because to me, if I'm doing add service, this doesn't look like adding something to a list. It looks like changing the value of add service. This, to me, looks like adding something to a list, right? And let's run this and see how we do. And so that's working good. And again, now we're cooking with gas. I just want to pause and check in and see what questions folks have around the code, how it's working. Maybe we haven't gotten to these guys yet, but I want if folks have questions about anything we've built thus far. Jesus, yes, sir.
On the init for like model year and mileage, I put string init. Why did you put like none and like blank strings?
Oh, you mean why is this an empty string instead of
Right. Just
instead of
str.
yeah. So year mileage are going to be integers, I've decided. So that's why I put none. I don't like changing the type of a variable unless I have to. I honestly don't like these empty strings here either, because I'd rather have none represent nothing. But if I put none as a default value, none dot lower is going to throw an error. And I don't, just in the interest of time, this was the easiest path. And I wanted to pass all of these as named arguments, because this is a lot. I know I'm gonna get the order of this stuff confused. And so when I make, my like Toyota, I want to be able to use keyword arguments. Right? I don't want to have to remember for 5 things in a row what order these arguments have to go in, because that's too much work, because programming is already complicated enough. Does that answer your question?
Yeah, thank you.
Yeah, absolutely. And this Toyota won't have any service done, so I don't have to pass that at all. And now we can look at our Prius. So we've gotten a huge amount of this program working. If I scroll back down to my to-do list, all this stuff here, this is done, the make, the model, the year, the mileage, the service, and I think you can see how breaking these into their own separate little steps and using print statements to do TDD as I go is really powerful. Now let's add the feature of we need to update the total number of cars. How can I do that?
New cars, total cars plus equals 1.
Yeah. So do I do self dot total cars plus equals 1?
Car manager dot total
Car
cars.
manager.
Yeah, exactly. Thank you guys. I think this would actually work. You shouldn't do it even if it works because it will makes it very hard to understand the code. We're accessing our class attribute. Similarly, let's go ahead, and I actually forgot to add an ID for my car. I'm just going to use total cars. I'm actually not going to use total cars for my car ID. Why do I not want to use total cars for my car ID? Why can't I just have, if total cars is 3, the ID is 3. When I add a car, it's 4, the ID is 4. Why is there a problem with that? What happens when we get rid of a car?
The total car count stays the same.
That I don't think is what we want. I don't think the problem is specific. And this is where Test Suite helps. But my read of this is if we add 4 cars and then I decide to get rid of one from the car manager, though this is maybe a little out of scope because it's not mentioned in the program at all. So we could save this for later, but I figured it's a good time to touch on it. Like if we have 4 cars in my dictionary, when we get rid of one, my reading is we remove it from the dictionary and we decrement total cars to 3. So I want to use a different value for my ID counter. This also lets me start the ID at 1, which I think makes sense for car IDs. Most things generally, like you don't, like everything is 0 indexed, but an ID of 0, because 0 is falsy, can cause potential complications. So let's go ahead and set self.id to car manager dot ID counter. And then let's go ahead and increment the ID counter. This is also nice because now whatever I do or don't decide to do with total cars, it has 0 impact on the ID, and it shouldn't. Those are separate features, right? I don't want the part of my code that keeps track of the total number of cars in my database to break the part of my code that creates IDs for my cars. And this way they're totally separate. And let's go ahead and let's just add ID to our dunder string method. I am going to be a little lazy and cheat here and just access the private variable and not make a getter for it. But you guys should make a getter. So I don't think we're going to worry about removing cars right now, but it's good to start thinking about this stuff. And even if you decide to do it later, to be aware of it. So now let's tackle, so now total cars should increment correctly. Right? If I take this print statement and I put it down here again, total cars is incrementing correctly. Now let's add cars to the all cars dictionary, and I'm going to do it by ID. Car manager sub self dot ID, and I am going to add a getter, because now that I'm using this in 2 or 3 places, I don't want to have to worry about if that ID name changes for any reason or anything. And I am going to use a getter here. that's the other advantage of getters and setters, by the way. Like, you know, what if we decide that under the hood, year needs to be named to like year released or something else? Well, I can change that under the hood, but everywhere that uses this code can still use the name year, right? There's a level of abstraction there. So I'm going to add that car to the all cars dictionary and use the car ID as the key. And I'm going to use the getter. I'm not sure if this getter will work in the constructor. We'll see in just a second. And just one moment, Owen. And indeed, it doesn't work in the constructor. You can't use a getter in the constructor. So here I will use the property directly. And I think that should work.
I think you have to do car manager dot whatever your car ID
Yeah.
or car dictionary is, then bracket.
Oh, you're so right. Thank you so much, Owen. Is that what you were going to say as well?
Yep.
Yep, thank you. So this is a great example, folks, of, I think this is actually the most common kind of error. I made a simple syntax error and then I jumped to conclusions about where the problem was and I started going down a completely wrong path. So Owen, thank you for pointing that out. This is also why writing like one line of code at a time is great, because I do that all the time. And so when I make silly mistakes and I go down the wrong path, just having one line of code to debug makes life easier. And so now we see we've got cars in our car dictionary, and we've got number of cars incrementing. And let me just pause and check in and see what questions folks have thus far.
I have a question real quick.
Yes, sir.
Are you printing out all of the cars? Was that your Dunder RE repper method that you, or is it?
No, that
where-
is just it
where
is
you
the Dunder
should-
repper. Yeah.
Okay.
So
So
I have
just-
the print statement on line 13, and
Okay.
we print car manager all cars. And because the car object has Dunder repper, Dunder repper prints stuff out nicely if you have objects in lists or strings. The Dunder str works for print statements, but if you have something in a list or a dictionary, excuse me, in a list or a dictionary, not a string, Dunder str does not work. Dunder str is good if we like using a print statement to show something to a user. Dunder REPR works for print statements and everything, and so it's a little more flexible. My recommendation is use Dunder REPR for representation. Start there. Jacob, yes, sir.
Yeah, so I have that problem of, I don't remember what you said you had to do to make sure it doesn't print off like the actual object. Like where it says like car management dot car manager object at 0x. Like I was following along with you, but I don't know why it does that. Like to actually try to, because I have it set up in like the return statement under the repper. And I tried doing it the same way, but yeah, it just gives me the actual objects. I have like Toyota, the make, model, year, and I'll try to do print Toyota, and it just gives me the object.
I would have to see the code.
Okay.
Put the code and the error message in Yankee questions, and I can look at it at the end of the lecture, or we can look
Okay.
at it on Zoom afterwards.
Okay.
Yeah, totally. All right, let's talk about class methods, right? Because this is a bit of a warm up. We can write methods like I wrote an add service method here, and here I can do Ford add service. I can do, Toyota add service, and that adds something to the individual car. Just like there are class attributes, there are also class methods. There are also class methods. And these are useful when we want to have some sort of functionality that is not specific to an individual car. That is not specific to an individual car, is when we want to have class methods. So, and let me look at my notes briefly here. We might decide that I want a class method that deals with talking to the terminal to get user input to add a new car. I can write it just like a normal method. A normal instance method, we would say self, which is just a placeholder. If I wanted to in here, I could name this to foo, but self is the convention. For a class method, we're going to use CLS. And this is just a placeholder, but it's short for class. And what we're also going to do, and let me put pass here so the squiggly goes away. We need to tell Python that this is a class method. I'm not going to do Toyota.prompt user to add car. That won't work. That's not how we want this to work. What I want to do is car manager prompt user to add car. And the way we tell Python this is with a decorator. And this is actually a pretty good description here in VS Code. A class method receives the class as the implicit first argument, just like an instance method receives the instance as the implicit first argument. Our instance methods, like add service, self is the instance, and that's sort of that first argument that's implicit. I don't need to pass it when I call the method. Here, we're passing the class itself, and we'll see we can actually kind of use the class constructor inside. So let's see what this looks like. So I want to prompt the user to add a car. I need to get the make. Let's just print enter info for car to add below. Make model year mileage. I'm going to make a programmer decision, a design decision that service, because it's a list, we'll do service. We'll say like maybe most recent service, so the user only enters one thing. So if this was in runner PY and I wanted to make a new car for this information, I would do something like this. Year equals year. Mileage equals mileage. Service equals service needs to be a list. And so in here, we'll put service item. Right? Just like I do over here on line 10 in the other file for the Ford and for the Toyota. But because we're doing this in a class method, this placeholder class is a variable that has the name of the class for us. So I can write the code that way, but I should write the code this way. And it does the same thing. And this way, if I change the name of the class, like my car manager, the name doesn't change. When we get into inheritance, it becomes a little more relevant. But mainly, this is also for other programmers to understand the intent here. That we're using this to create a new car. So, and I can show a couple other examples of class methods as well. I think that will be helpful, but let's run this code and see what it looks like. So let me just comment out all the things adding print statements. So we just see prompt user, and then let's run the code. Owen, yes, sir.
You're probably gonna get it. You might get an error because you're putting the year and mileage as a string with that class method. Probably need to
That is a
change
great call.
integer.
Thank you. I totally forgot about that. We are definitely going to need to cast year and mileage integer, which is a great example of why these class methods are actually useful. And in fact, I don't even need this. Well, I can have it if I want. The class method doesn't have to return anything. That's up to us. Let's start with just this and see what this looks like. And then at the end here, let's just print car manager dot all cars. So let's make a we'll make another Ford. It'll be a Taurus. Oh, and thank you for pointing out the year. That definitely would have thrown an error. 2020 mileage 100,000 miles. Most recent service, I'll leave it empty. And so now we see printed out in the list of all the cars in that class attribute are Ford Taurus. Because the CLS is just a placeholder for car manager, for creating a new instance of the class. So class methods, you don't use them all the time. They are usually used for things like this. Like creating a new instance of the class in a certain way is a great example. For instance, the fact that I have to do like this casting, like to get the user input, that's good to put here. I might make another class method. Maybe it's going to be I'm into Fords, so like add Ford. And the make is going to be Ford. What's another Ford? What's like a truck?
F-150.
Sorry?
An F-150.
Yeah, there we go. That's what I was thinking of. Oh, so model, I don't want to hard code. Excuse me. Model, year, mileage. Actually, let's make this even more interesting. Let's say like add new Ford. So the mileage I know is going to be 0 because it's a new car. And in fact, now that I think about it, I should have just set mileage its default value to 0, but that's okay. Add the year. Well, this does raise an interesting question, like where do we want to put the year? Let's just, for pretend, let's say I'm hard coding it in here. So year 2024. Really, maybe what I want to do is current year equals 2024. And then over here, I can do class.current year. And the model is whatever model we pass. And then the mileage, because it's a new car, will be 0. And so over here, let's go ahead and use this to add a new Ford, and we'll add an F-150. And year I don't want to pass in as an argument because I'm grabbing it. So, right, I could actually write this, that would work. But since this is in a class method, This way is a bit cleaner. It tells other programmers what's going on. And if we ever change the name of this class, and also when we get into inheritance, it does it for us. And now let's print out car manager, all cars. And see this printed out there, and hopefully we should see our F-150. Oh, and it's prompting me, man. And this is the problem with user input. There we go. So the Taurus we can ignore, but over here we see our Ford F-150. So class methods, you don't need to use them all the time. Let me walk through a little bit of best practices of when to use class methods versus instance methods, because I think that's a common question and an understandable one. And in general, the rule is you can just use instance methods. So let's put this in the README and let's talk about class versus instance methods. So instance methods. They are your bread and butter. You use them most of the time to do stuff to specific objects with their own attributes. Class methods do not operate on a specific object. You know, I can't do car manager, add service, because what car am I adding that service to, right? This is an instance method because I'm adding the oil change service to a specific car. But something that's not about a specific car, like add new Ford, is a great example of when to use a class method. They're often used for custom constructor object creation. Like a great example of a class method is, if we think about, just to switch gears and think about shapes, if we had a rectangle class where we're like creating a rectangle, just the shape, and you know it's going to have an X and a Y, and we're going to do something really simple. And we would use it, you know, like this. A rectangle with, you know, a width of 5 and a height of 10. Well, what if we want to make a square? The square, both sides have the same length. So this is a great example of where a class method can be useful for sort of like custom object creation. This is probably the most common way you would use class methods. Most of the time you wouldn't. Another example of a class method could be to get a car by ID, because we have all cars, and let's find that particular car that we're looking for and return it. Or possibly to remove a car. Because to remove a car, I need to get it, first of all. So actually, let's just use our get car method. And what this does for dictionaries, get returns none if it doesn't find anything. Because what if the car doesn't exist? So if the car doesn't exist, if the car does exist, if car is truthy, then let's I think it's delete. I think that's how you delete from a dictionary. If someone knows if that's wrong, please let me know. And then we want to decrement the total number of cars. Otherwise, let's print car not found. And I think that that should work. And we can test that out. Right? And these are operations related to the class as a whole. I can't do, I guess I could do Toyota.remove car. That might actually be useful, right? Or like my Prius.remove car. But it wouldn't make sense to do like my Prius get car 4. If I want to find the car in our dictionary that has an ID of 4, that's car manager get car 4. And similarly, car manager remove car, with an ID of 1. And in fact, let's just run this code real quick and make sure that it works. And we're almost at time, so this is definitely a good stopping point for questions. And let me comment out the prompting because that takes up a lot of time. There's one more thing I need to take a couple minutes past noon to cover. I do apologize, static methods, but that is a variation on this theme. And let me just fix my typo that it looks like is on line 22. Let's see, and that is line 22 in the runner.py. And that's just because I misspelled remove car for our remove car method. And in fact, VS Code gave me a hint with that color gray. And so there we can see here the car got printed out. And if I look at this list here, I see that it's been removed, right? And if I look at the code, this makes sense. Just intuitively, it makes sense that the car manager is what I would call a get car or remove car or an add car methodon. So I want to pause and check in and see what questions folks have, because I've been doing a lot of talking and covering a lot of ground. What's on people's minds? This is definitely a good time to ask about things that might be good to review. Owen, yes, sir. I see your hand up.
So obviously the easiest way to add each car is to put that unique ID. So like 1, 2, 3, 4. What if we wanted to, on your input, like when you're going through your inputs, like what do you want to name
Mhm.
the car? And you say wife's car. And how could you get that object to be made then where it's named a wife's car? Because like I imagine you
Yeah,
need a dictionary with the key as wife's car and then all of like the car make model year
yeah,
whatever.
that's a
How
great
would you
question. That's a great question. And really what I would say is, so there's a bit of a design question here. In some ways, this class is misnamed because an individual object is a car, right? And it's easy to lose sight of this now that we're adding all this stuff. And in some ways, if I was doing this at this point, I might make a separate car class for all of this stuff because it makes a bit more sense to me. But to answer your question, we would just add on attribute, let's just call it nickname, just to make it clear. Because the only reason I want to avoid name is I know I'll confuse it with make and model. So nickname, I think, makes it clear that this is coming from the user. And we would put that there. And then over here, if I want to prompt for it here, we can just nickname equals car name and nickname. And then this is also the nice thing about using the named arguments. I suppose I need to add it for add new Ford as well, actually, because over here, nickname is that, and we got to pass it in there. So there's actually like I probably like an add car class method might be useful, but like wife's car, and let's bring back in the prompt and we can watch that happen as well, and we can see what we end up with. And let me just get rid of removing the car in case we accidentally remove the car that we add. I'm not sure how the IDs play out. So Ford, oh man, Ford Ranger, the other car, I meant to type 2020, that's okay. And I'll just leave that empty. And we're not seeing the nicknames printed out because I also forgot to update the Dunder Repper method. So let me fix that.
Before
Now.
you go any further, Adam,
Yeah.
I was asking like how could you set so like instead of 1, 2, 3 being like how you identify that class,
Oh, got
how
it.
could you make a nickname? So like I was thinking like
Got
you
it.
could
For
put
the
like
dictionary.
if this was for like a auto shop, like we need to know the client's name. That's how we access their car and see their service records.
Got it. Like this is what you're saying.
Yes.
So it looks like
Yes.
this instead of like 1 and 2.
Yep. Exactly. That's what I was getting after.
Yeah. You totally could. You would just have to, instead of like over here,
Yeah, if that's
where
going
we
to be too
set,
extravagant to explain within this time, that's totally fine. I can.
yeah, I'm not going to build it out. But just on line 45 here, where we set the ID, we can set it to a string. We would have to modify the rest of the code accordingly, but there aren't a ton of changes. The reality is you may not actually want to do that because how do you remember the name of the car? What if you forget the name of the car? Though you might want to. It just depends. And also if you're using a string, like what if there's an apostrophe? Are you uppercasing or are you lowercasing? When you're using strings as dictionary keys, you just need to be a little more thoughtful. But then like I think what you're touching on too is like find car by name, like get car by name. And you
Yeah,
absolutely
like
can write that as well.
yeah, it's not
Um,
very humanish. Put car number 1 or car number 2. It'd be like this person's car, and then you'd obviously have to follow some formatting, so that way you could actually find it. But
yeah. So pretending that our cars have nicknames, we can actually do something like this. For car in class all cars dot values, right? And I believe dot values returns the actual values of a dictionary and kind of turns it into a list. If car dot nickname equals nickname, return car. And so that's where Python is kind of awesome, that this dot values will take all the will bundle up those key value pairs in a dictionary and give you just the values. Each of those themselves is a dictionary. I'm sorry, each of those is an object. So we would just do a string comparison here. Yeah, great question. I don't want to get into refactoring to create a car class, though at this point we really deserve one. We really deserve a class that looks something like this, I think, for our sanity, if nothing else. Right, and now maybe we do need to pass in an ID because we're no longer doing it. And this makes sense. And then we could like use that inside here. Right, and things could change a bit, but the car manager works pretty well. It makes sense. It keeps stuff all in one spot. The last thing I want to show, and then we will break, is something called a static method. And a static method is a little different from a class method. So, fair warning, this is a general point of confusion. When should I use a static method? When should I not? The short answer is you usually don't need a static method. You usually don't need a static method. A static method is independent of both class and instance state, and they're usually used for utility functions. And a good example of this is, let's say, and you create it, of course, with a decorator. Because a static method is completely independent of the class itself, we don't need class or self. None of that gets passed in. Maybe I want to make sure the make of the car is valid. And this is a tiny list, but it gets across the point. And in fact, I can just return, because that should return a Boolean. And if I'm using this, and let me comment out these print statements, and let me comment out this prompt, it would just look something like this. Car manager dot is valid make Ford, and that should return true or false. And let's see where my syntax error is. I stuck a semi that think I was trying to do a semicolon, or it was originally an if statement. But let's say instead I do Chevy because it's not in there. Or a better example is I misspell Ford. And so you could see how this is useful. It's a utility function. Maybe someone else needs it. It's not connected to a specific car. If I wanted to, I could even use it inside other methods as validation logic. You don't write a ton of static methods. When you do, it is usually for validation logic or utility stuff like this. Like a great example might be is valid year. You know, and let's just do like year equals a year cast to an integer. And we can say, you know, if year is greater than, I don't know, 1800 when the first car was created. I don't even think we need a less than. Maybe our code will run for 1,000,000 years. And we can just return true or false. And then over here, if, you know, as I keep doing, instead of like a 2000 model car, I accidentally type a 200 model car. This should tell us that it's false. And maybe someone else wants to use that code, but they don't need to create any cars. So that's why it's a static method. You don't use them as much. I think the most common point of confusion is when do I use a class method? When do I use a static method? If you're doing a custom constructor, it should probably be a class method. If you're doing stuff with class attributes, probably a class method. The truth is you can use them interchangeably. Try to just use static methods for utility stuff. Start with a class method and go from there. I've been doing a lot of talking and we ran a bit long, so thank you guys. If there's one or two questions, I think we can take it and then we should definitely wrap. What's on people's minds of what might be useful to go over around class methods and static methods in particular?